Conversion of Fisher projection into Haworth projection and vice versa. Conversion of Fisher projection to Haworth projection. Look for the chiral carbon in the Fisher projection, a carbon that has 4 different groups attached to it. This chiral carbon becomes anomeric carbon, carbon that has 3 different groups attached to it, which can be a ketone or an aldehyde carbonyl functional group. Bend the chain, the skeleton of the carbohydrate structure, into a cyclic structure by attaching the last OH, hydroxyl group that is attached to the chiral carbon, to the anomeric carbon atom at the top of the Fisher projection. Place the anomeric carbon, the carbonyl functional group, at the top of the cyclic ring. Direct the position of the hydroxyl groups above or below the ring based on their position in the original Fisher projection. The horizontal lines become groups pointing above the cyclic structure of the Haworth projection. These are groups located on the right side of the original Fisher structure. The vertical lines become groups pointing below the cyclic structure of the Haworth projection. These are groups located at the left side of the original Fisher structure. The last carbon atom that is attached to the last OH group is always positioned at the top of the cyclic Haworth projection. Conversion of Fisher projection to Haworth projection D. Glucose. Conversion of Fisher projection to Haworth projection. Fisher projection and Haworth projection. Given the following Fisher projection, which of the following is the correct Haworth projection for alpha D, glucose? These are 4 multiple choices. Select the correct answer among these 4 multiple choices. Answer is multiple choice C. From Haworth projection to Fisher projection. Look at the non-chiral anomeric carbon atom, which is carbon number 1 at the hand drawing below. Now try to make the cyclic Haworth projection flat and place this anomeric carbon, carbon number 1, at the top of the flat chain. Start numbering the carbon atoms of the chain from the right to the left of chain, with the anomeric carbon being number 1. Assign the hydroxyl groups on each carbon as either horizontal, pointing towards the viewer, or vertical, pointing away, based on their position in the Haworth projection. The OH groups at the top of the Haworth cyclic structure will be placed are at the left side of the Fisher structure. The OH groups at the bottom of the Haworth cyclic structure will be placed are at right side of the Fisher structure. Conversion from Haworth projection to Fisher projection. Example of C conversion from Haworth projection to Fisher projection.